Welcome to this introduction on bills of material, or BOMs, in Windchill PDMLink, and be aware that this video is going to be focused more on the philosophy and background to bills of material. There won't be any picks or clicks. This will be a lecture style video, so if that's not your jam, hey, you probably want to jump out of this video right now. But first off, let's talk about the different kinds of bills that you can come across in the product development process. First off, you could have a bill of systems, which is used in planning. And then, as we're talking about in this video, you can have a bill of materials, which is used in engineering and procurement and the supply chain. You could also have a bill of characteristics, which is used in the inspection process, and a bill of process, which is used in design for manufacturing, and also a bill of substance, which is used in DFE, the development for environment field. So let's talk about the different standard bills of material that you can come across. And we'll talk about these in more detail on the next few slides. You could have the eBOM, which is the engineering bill of materials. You could also have an mBOM, which is the manufacturing bill of materials. There's also a purchasing bill of materials called the pBOM. And lastly, there is a bill of materials that can be used by finance and planning. They don't call it the FBOM because when we say FBOM, you know what everyone thinks. Instead, they call it the finBOM. So let's talk more about this thing called the Engineering Bill of Materials, or eBOM. First off, it reflects how your designers approach product development, how they say, okay, what are the different components that we're going to need, the parts and assemblies, how are we going to put them together? And this is going to come from the CAD model. Your CAD assembly is going to generate the eBOM, and it'll be automatically updated when you check in your assemblies to Windchill. And this is going to be the upstream source for all the different downstream deliverables. Besides the eBOM, we also have the manufacturing BOM. And the reason that we have a different BOM for manufacturing compared to engineering is that the eBOM will often contain too much detail to be used by manufacturing. And we'll talk through a few different scenarios later on about why the eBOM can't be used by everybody. And so the manufacturing BOM reflects how someone is actually going to manufacture the different components, assemble them, and put them together. So for example, often in engineering, you might group your assembly, your product, by function. You might have a structural assembly, an electrical assembly, hydraulics, mechanisms, but manufacturing might need your organization to be done by the location of the different components. Also, depending on where your product is going to be manufactured or assembled or integrated, you might have different manufacturing bills of material for different plants based on where the different stations are located throughout there. And the way that you create the manufacturing bill of materials is by transforming the engineering bill of materials. So for example, you might restructure it, you might get rid of certain assembly hierarchy, you might add more assembly hierarchy, you could replace different lines from the engineering bill of materials with other lines, and you could delete components and add components as necessary. And so then once you have this manufacturing bill of materials, this is going to be the input to your manufacturing process planning so that they can generate the process plans to be used by the different teams for assembling your final products. Next, let's talk about the purchasing BOM. And the people who use the purchasing BOM is your procurement and your supply chain. And so what happens is that the purchasing BOM in some situations can even be the same as the manufacturing BOM. Not always, but it's possible. And so the way that the purchasing BOM works is that it's going to be structured based on how you're going to procure your different components. So for example, You might have your composite structures organized differently in the pBOM versus the mBOM and the eBOM. Same thing for your cabling and piping, and also your commercial off-the-shelf components, maybe like your fasteners. Maybe you're going to organize them into their own separate area in the bill of materials as opposed to being in the same structures as your different assemblies. And so once you have this purchasing BOM, this is used by your MRP or your ERP systems downstream. And the last one that we'll talk about is the finance BOM, also known as the finBOM. The finBOM is used by the financial planning and accounting teams. And the point of the finBOM is to get your cost projections, because what the finBOM provides is a true cost of the product. And the way that the finBOM calculates the true cost of the product is that it's going to take into account the cost of the different components times the quantity of those components, plus the labor cost, the number of hours that are necessary to manufacture and assemble and integrate the components into the final product, times the average labor rate. And then it's also going to factor in any necessary administrative and overhead costs. So again, you're going to end up using the finBOM to calculate the true final cost of the product. According to a group called INEMI, there are three main sources for errors in your bill of materials. First, there's completeness. Oftentimes when people are putting together your engineering bill of materials, hey, they might forget to include certain components. Maybe they might forget some fasteners. Maybe they might forget some helical inserts. Also, people might not have their approved manufacturing list, the AML, or the approved vendor list completed. Another major source of BOM errors is correctness. Sometimes you can have discrepancies. Maybe you have implemented different change notices, but those change notices didn't work their way back to the engineering definition. It happens. And the third source where you can have BOM errors is consistency. You're not following the same process in how you create your bills of material across different product lines, and they're not used downstream in the same ways. So let's talk about why can't everyone use the engineering bill of materials, or why can't there just be one single bill of materials that's used throughout your entire enterprise? So first off, let's take a look at composite parts. So the way that composite parts are designed in CAD is oftentimes you'll end up modeling each individual ply of the composite as its own individual part. And if it's its own individual part, in CAD, it's going to have its own individual part number. But once you figure out what this composite part is going to be, you're going to go out to your manufacturers, and they're going to take care of building the component. They're going to deliver it to you often as a single unit. So often in the manufacturing bill of materials, you want to replace that assembly with all its individual parts for each individual ply as a single line item in your manufacturing bill of materials, or maybe even your. So often you want to replace that CAD assembly with its own individual parts with a single line item in your manufacturing bill of materials and your purchasing bills of material. Next up, cable harnesses. So the way that you design a cable harness assembly in CAD is that it's going to consist of at least three components. You're going to have connectors on each end and a cable part in between. But oftentimes, a cable harness will have more than just two connectors at the ends, plus you're going to have a whole bunch of other accessories like back shells and terminators and multiple different branches and sheathing, boots, all sorts of stuff in there. But when these cable harnesses are manufactured in the manufacturing bill of materials, you often want them to be represented by a single line. Also, another situation with cable harnesses is that often you use commercial off-the-shelf cables. So for example, you have a USB cable. And if you model this USB cable in CAD, it's going to have its own part number. And again, it's going to have connector component, it's going to have a cable harness part, but you just want to replace it with a standard part number from the real world for a USB cable. Very similar to cabling, also on the piping side, you have the same situation. In a piping assembly, you're going to have flanges, fittings, elbows, valves, reducers, plus the individual pipe solids that connect them all together. And again, you have this entire piping assembly with all the different components. Often you want it to be a single line in the eBOM, the pBOM, or the finBOM. Most products contain a lot of commercial off-the-shelf components, and so those are often modeled as sub-assemblies, but in the downstream bill of materials, also you want them reduced down to a single line to reflect the component that is going to be purchased. And be aware, starting in Creo 8, you have inseparable assemblies so that you can have these different COTS components, which are assemblies in CAD, actually just a single object. So let's talk about this process of transforming BOMs from the eBOM to other different varieties of bills of material. First, let's review some of the different kinds of objects that you're going to have in Windchill. You have your CAD authoring platform, Creo Parametric. In there, you're going to create different parts and assemblies. And when you check your CAD documents into Windchill, you can create what are called enterprise parts or WT parts or Windchill parts, or as people call them, just parts. So some people will also refer to them as gray gears because that is the symbol used in Windchill to represent them. And you can also take some of your WT parts, your gray gears, and say that this is an end item. And be aware that an end item can contain other end items. And an end item is just a special designation for a WT part to say that, hey, this is a distinct unit that we are going to sell or we are going to manage as a complete unit. Besides having your regular gray gears, you have other different kinds of Windchill objects like manufacturer parts and vendor parts, and those are also with the gear symbol, but they are different colors. And you use the manufacturer parts to generate your approved manufacturer list, your AML, and you use the vendor parts to generate your approved vendor list, your AVL. So why do we need these Windchill parts? Why can't we just use the CAD parts and the CAD assemblies that are generated by Creo Parametric? First, often in your bills of material, you want to represent items that you're not going to model physically. So for example, you have some different COTS components that you're going to use in your products, and you don't have models for them, and you don't need to put them in the CAD model. So you can just add them into your product structures in Windchill using one of those WT parts, one of those gray gears. Also, a lot of times you want to have a representation of your product as it's going to be shipped to the customer. So for example, you might want to include the different documents like a manual or a warranty card that goes along with the product. Plus you might also want to represent the shipping box, any different shipping materials that go along with it. Another reason for using these Windchill parts is so that you can manipulate the bill of materials without changing the CAD model. Now, one time in one place that I worked, our manufacturing group, they wanted us to go back and change our CAD models to reflect the manufacturing bill of materials. They just wanted to have one single BOM, the eBOM that was used throughout the organization, and that would have resulted in hundreds, if not thousands, of unnecessary work by the design engineers when they could be doing engineering of the next generations of products. Hey, we have these Windchill parts. We're able to transform an engineering bill of materials into a manufacturing bill of materials, a purchasing bill of materials, a finance bill of materials. We don't have to have one single bill of materials to rule the entire enterprise. And in addition to creating these other different kinds of bills of material, maybe you want to create other different product structures. For example, maybe you want to create a mission kit for how your different products are going to be used. So for example, when I worked in drone design, hey, we would have our vehicle, but maybe we would also have some additional controllers, some other different receivers and antennas that we wanted to represent in a product structure. Also, you might want to create a replacement parts product structure or a spare parts product structure. And lastly, you can also create as-built and as-maintained configurations in Windchill. So again, you have how you say that a product should exist theoretically in a perfect world, but then as you're building it, sometimes you're going to have different waivers and deviations to reflect, hey, this component didn't come in, so we built the product without it. Or what you said to use wasn't available, so we used this instead. And so that way you can develop an as-built configuration of the product that's different than the one that's defined from engineering, which you might describe as the as-planned configuration. And then as you make different changes to that product in the field through maintenance or repair or overhaul, you might want to maintain a different configuration, which is the as-maintained configuration. In other words, what does this look like today as a result of being in operation? So we have other additional BOM functionality that we can use. First off, replacements. And your replacements can either be alternates or substitutes. Here's how I remember the difference. An alternate says that a component can replace the other component anywhere, and with a substitute, you're saying that this component can replace another component only in a specific assembly. Alternates anywhere, substitutes specific. And they can be one-way or two-way. So we could say that, hey, whenever you have connector A, you can replace it with connector B, and wherever you have connector B, you can replace it with connector A. That's an example of a two-way replacement. But if you say that, hey, wherever you have connector B, you can replace it with connector A, but you can't replace connector A with connector B, that is a one-way replacement. Another functionality that we have for BOM management, as I've mentioned a few times before, we can use our bills of material in order to identify the components that we're allowed to use from our approved manufacturer list and our approved vendor list. What's the difference between a manufacturer and a vendor? Well, the manufacturer is the organization that actually builds the component that you're sourcing from them, but the vendor is the reseller of the components. So for example, I used to work in cable harness design, and you have companies like Amphenol that make different connectors, but then maybe you're going to buy that connector off of DigiKey. So Amphenol is the manufacturer, DigiKey is the vendor. And the important thing about creating these different manufacturer lists and vendor lists is to define a sourcing status for the different components, and they can be out of the box defined as approved, preferred, do not use, or single source. And also you could use your BOM functionality for configuration management. In Windchill, you can actually serialize the different components. In other words, you could create unique identifiers for objects that are created in the real world. And you can also perform allocation to say that this serialized component was used in this particular serialized end items. And also you can define reference designators. A car has 4 different tires. You could have a reference designator in order to distinguish the front left tire from the rear right tire. So let's take a look at the basic process for transforming an engineering bill of materials to a manufacturing bill of materials. First off, you are going to open the engineering bill of materials in your Manufacturing Product Structure Explorer or Manufacturing Product Structure Browser. Then you can create a downstream manufacturing view from the upstream design view. In other words, you are creating the mBOM from the eBOM. Then you do what I like to call slice and dice. You are going to manipulate the engineering bill of materials into the manufacturing bill of materials. And there are a number of different operations that you can perform. So for example, you might replace some of the objects in the engineering bill of materials with new or existing Windchill parts that are in your common space. You could create new Windchill parts. You can remove different assembly levels. You could move components from one assembly to another assembly. You could create new downstream part numbers. You can delete stuff. You can copy and paste stuff. Hey, you're going to do whatever you need to do in order to turn that eBOM into your mBOM. And once you are finished, you are going to check it into Windchill. And then, if necessary, you can release your manufacturing bill of materials by a promotion request or even a change notice. Now, one thing about engineering bills of material, you do need to perform maintenance on them in order to ensure that they are accurate. And here are a couple things that can happen to make your engineering bill of materials be incorrect. Sometimes if a person doesn't know what they're doing when they're performing different operations like revise or set state or promote, they can break the link between the engineering objects, your CAD parts and assemblies, and your Windchill parts. Also, during editing, you can actually cause the CAD document and Windchill part to be out of sync if you're updating certain information in the Windchill part. So you just want to make sure that your engineering bills of material are up to date. And to do that, you have tools like comparing the CAD structure to the part structure and the tool to build the part structure, which allows you to repair and resync the two product structures. Also, you're going to need to do maintenance on your manufacturing and purchasing bills of material, because often what happens is that you create the mBOM and or the pBOM before the eBOM is released. You want to work on them in parallel. You don't want it to be a serial process because that takes too long. After the eBOM is released, you might end up revising it, changing it. So you want to make sure that you update any changes to the eBOMs to your mBOMs and your pBOMs. And in Windchill, you have tools like doing a comparison report. You could update the equivalence links, and you can use the other different transformation tools that we already mentioned. And so hopefully this gives you a quick high-level 50,000-foot view to the management of bills of material in Windchill. Thank you very much. I hope you enjoyed this presentation.